OK, that's it for intrusion detection. Here's your summary. We saw 3 different ways you can install detectors. This is telling us where the detector goes. You can put it on the network, which makes a NIDS. You can install them on the end hosts, creating HIDs. Or you can generate logs and analyze those logs using scripts. These are all valid places to put detectors. NIDs tend to be cheap, but they have the drawback of inconsistent interpretation, leading to evasion attacks. By contrast, HIDs might be more expensive because you have to install on every end host, but there might be fewer inconsistencies because the detector and the end host are at the same place. And with logging, it's cheap, but it can only detect attacks after they happen. Then we looked at ways to measure detection accuracy. We looked at false positives and false negatives, the 2 types of errors that can occur. And we said that designing a good detector means balancing the 2 rates. And finding the perfect balance depends on other questions too. For example, what are the costs of false positives and false negatives? And what is the base rate attack on your system? And remember, the base rate fallacy said that if you have a lot of legitimate accesses and only a few attacks, even a very good detector going in and scooping up a bunch of flags will probably get tons of false positives in addition to the attacks. So accurate detection is very hard if the base rate of attacks is low. And we saw ways you can possibly combine detectors, and those lead to trade-offs as well. Then we looked at 4 ways to detect attacks. Now we're not looking at where you put the attack or the detector, but how you detect the attacks. You can use signature-based, keep a list of what's not allowed, flag if it is on that list. Or you could use specification-based detection, keep a list of what is allowed, which you specify manually, and flag if it's not on that list. You could use anomaly-based detection, use machine learning, come up with a model of normal activity, and flag on anything unusual. Or use behavioral detection, where you ignore the input altogether and look at what the input did and alert on evidence of compromise. And these all have various benefits and drawbacks. For example, signature-based detection can detect known attacks. Specification-based is good at detecting unknown attacks. Other trade-offs like that exist. And at the very end, we showed you vulnerability scanning, probing your own system with attacks before you released your system to the world, honeypots, sacrificial systems that catch attackers trying to access them, forensics, analyzing what happened after the attack happened, and intrusion prevention systems, which extend detection to also actively block attacks. So that's it for intrusion detection and the networking unit. And coming up next, we just have a couple extra special topics that we do at the end. And that's it for CS161.